Okay. Uh, Good evening, everyone. Welcome to this live session on 17/12/2025. Okay, so in this live session, what we do is we'll do kind of, revising the sessions, revising the concepts. Okay, so some of the concepts at least. Okay, so through examples. Okay, so I think in previous live session, Vasumati has done this uh, for state space analysis, I guess. Okay, so now we'll do something different for some one or two problems on frequency response and some for time response. Okay, so let's see how many problems we can solve in this given period. Okay, so first I'll write down the problems, then we'll go one by one. Okay, so first problem what we do is, okay, so we have a transfer function is given to us. Okay, so minus 10 s minus 3 divided by s plus 1 s square plus so 25. Okay, so so you can see these are the revision of concepts. If you're having any doubts, you can ask, and some of the concepts may be very familiar to you. So they seem to be very trivial problems. Okay, so what do we do here is, let's say u of t is the input, y of t is the output. Okay, and so first question. Okay, so we need to find DC gain of the system. So second one is find the poles. So third one is suppose if u of t is equal to 0, okay, and consider initial conditions are 0. Okay, so find y of t for t greater than or equal to 0. Okay, and fourth one is, let's say u of t is, if u of t is 2 mu of t. Okay, where so mu of t is the where mu of t is step function, then we have to find y of infinity. We have to find y of infinity, steady state value of the output. Okay, then then let's say when u of t is equal to mu of t. Okay, so draw the plot. Draw the plot with initial conditions 0. Okay, so this is one problem. Okay, then let's say second problem which we wanted to consider is, let us say, given so g of s is equal to 8 by s plus 10 whole square. Okay, and u of t is given as so 2 sine 3t plus pi. Okay, plus 4 sine 4t plus pi by 2. So find y of t expression. Okay, so this is going to be the second problem. Okay, then we'll see one more problem from the frequency response. Okay, so consider g of s. as 8 by s plus 1 whole cube. Okay, so we have three questions. Okay, so draw the Bode plot of g of s. Okay, then uh, Bode plot of g of s. That's it. Second is find phase margin and gain margin of the system. Okay, third one is also draw the Nyquist plot. Nyquist plot of g of s. Okay, so we'll try to cover these concepts. One problem related to time domain response, another is uh, related to the frequency domain. Okay, these two topics we will be covering today, and some more examples we'll cover on coming Friday session. And you can also ask your doubts in Friday session. Okay, so let's start with one by one. Okay, so the first question or intention here is to for the given transfer function, find DC gain poles when u of t is equal to 0, find y of t when u of t is 2 mu of t, find steady state value of output when u of t is equal to mu of t step input, draw the plot with initial conditions 0. Okay, so let's see first solution. Okay, so g of s is given as, so minus 10 s minus 3 divided by, so s plus 1 s square plus s plus, so 25. Okay, so first question is we need to find the DC gain of the system. So DC gain, so which is also known as what? Steady state gain. Steady state gain of the system. So how do we find DC gain or steady state gain? So DC gain K is nothing but what? Limit S is tending to 0 G of S. So when frequency becomes 0, we'll get the when frequency is tending to 0, we'll get the DC gain. Okay, so in this case, so how is it going to be? Limit S is tending to 0 minus 10 S minus 3 divided by S plus 1 S square plus S plus 25. Okay, so this is going to put minus 10. So 0 minus 3 divided by 0 plus 1, 0 square plus 0 plus 25. So which you will get as 6 by 5. Okay, so 10 and here, sorry, 30 by 25 is 6 by 5. That is the DC gain. Okay, next. So second question is we have to find the poles. Okay, so to find the poles, what we do, we have given g of s as n of s by d of s. Okay, so d of s, what do we have here? So we have d of s as s plus 1 s square plus s plus 25. Okay, so n of s is what? Minus 10 s minus 3. Okay, so what are the poles? So poles are nothing but p is equal to minus 1, and here the roots of this part. Okay, so if you use this minus b plus or minus raised b square minus 4ac by 2a. So you will get what? Minus 0.5 plus r minus j 4.97. So zeros are what? Two zeros are z is equal to 3. Okay, so this is our third question. Okay, next we have mm, third question is when input is equal to 0. Okay, for all t. Okay, so and initial conditions are 0. So initial conditions. So are 0. What will be the output? What will be the output here? So what do we do? So so how do we find since there is no input here? So how do we find? First we take g of s. Okay. So minus 10 s minus 3 divided by s plus 1 s square plus s plus 5 square. Okay. So how do we find? So generally we divide this into uh, a by s plus 1 plus so bs plus c by partial fractions s square plus s plus 25. Okay, so what is our next step is going to be so the next step is going to be so to find these a and b expressions. So what do we write here? We are going to have s plus 1 s square plus s plus 25. Okay, so a multiplied s square plus s plus 25 plus bs plus c. Okay, so s plus 1. So first we are trying to dividing the entire this thing into different parts. Okay, so how do we write this? Minus 10 s minus 3 equal to as square plus as plus 25a plus so bs square plus bs plus cs plus c. Okay, so by comparing the terms, okay, so you can compare s square term, s terms and constant terms. So first case we get 0 here. Here we get a plus b. In the second case minus 10 a plus b plus c. Third case it is 30 here. Okay, then this is going to be 25 25a 25a plus c. Okay, so these are the three equations we got. Now solving these equations, okay, so we get what? So we get a is equal to 8 by 5, b equal to minus 8 by 5, c equal to minus 10. Okay, so now if you take up this expression again, okay, so this expression you can substitute a, b and c. Okay, so we have a as 8 by 5, b as minus 8 by 5, c as minus 10. Okay, so that is our g of s equation is. Now our equation we have to find for the given input u of t is equal to 0. So we get its Laplace domain as 0. Okay, so here we have g of s as transfer function as y of s by u of s. Okay, so it means y of s is nothing but g of s multiplied u of s. So in this case, since u of s is 0, u of s is 0. Okay, so we can get uh, we can get we can get u of s is equal to 0. So y of s is 0, y of t also you can get 0. So that is one case, or else you can also write it like u of t is equal to, so g of t you can find its impulse response, then its convolution with u of t. So in that case also u of t is already 0, you will get, so this as 0. Okay, so that is next question. Okay, so third question, this is third question. Next, fourth question is, okay, so when you have fourth question is when you have uh, fourth question is when you have u of t is equal to 2 mu of t, where mu of t is the step function. Okay, so u of t is equal to 2 mu of t, where mu of t is the step function. Okay, so what is the expression in this case? Okay, what is question is what is y of infinity here? Okay, so now what you do, you can write to u of s as 2 by s. Okay, so now g of s is nothing but y of s by u of s. Okay, so that is given as minus 10 s minus 3 divided by s plus 1 s square plus s plus 25. Okay, so y of s is nothing but, so minus 10 multiplied s minus 3 divided by s plus 1 s square plus s plus 25 multiplied u of s. Okay, so that final expression is minus 10 s minus 3 divided by s plus 1 s square plus s plus 25 multiplied 2 by s. Okay, so now our job is to find y of infinity. So that means using final value theorem, okay, we can write y of infinity as, okay, so limit, so this is what final value theorem, that is final value theorem. Okay, so we can write this one as s is tending to 0, yes, y of s. Okay, so limit, so that is s multiplied minus 10 s minus 3 divided by s plus 1 s square plus s plus 25 multiplied 2 by s. Okay, so this s and this s gets cancelled. Okay, so s is tending to 0 if you find it. Okay, so you will get 12 by 5, so which is equivalent to 2.4. That is the final value of the system. Okay, I hope this is clear. Okay, any queries as of now? Okay, so that is fourth question. Next question is fifth question. We have to find y of t. So when u of t is equal to mu of t, what is y of t expression is? What is y of t expression? Okay, so now we can write from y of s is equal to g of s multiplied u of s. Okay, here u of s is nothing but what, 1 by s, so we can write this one as minus 10, so s minus 3 by s plus 1 s square plus s plus 25 1 by s. Okay, so which we can write it is as a by s plus b by s plus 1 plus c by, sorry, plus cs plus d by s square plus s plus 25 using partial fractions. Okay, so you can do that exercise. You can compare the terms, both these sides, compare like terms, both sides. Okay, so if you do that, you will be getting A as 6 by 5, so B as minus 1.6, C as 0.4, D as minus 1.2. Okay, now if you substitute them in this equation, okay, so you will be getting y of s as 1.2 by s, okay, 1.2 by s plus minus 1.6 by s plus 1 plus 0.4 s minus 1.2 by s square plus s plus 25. Okay, so that's what we are going to get. Okay, now our job is to find y of t. So how can you write this? 1.22 by s plus minus 1.6 by s plus 1 plus this last term we can write it like this, s square plus s plus 25 minus 1.2 by s square plus s plus 25. Correct? So how can you write this one now? Suppose here what is it, s square plus uh, you can see here we already know the Laplace transform of sorry, Laplace transform of e power minus at sin bt. Okay, so what is it? B by s plus a whole square plus b square. Similarly, Laplace transform of e power minus at cos bt, which is nothing but s plus a by s plus a whole square plus b square. Correct? Okay, so now we can use these two things and write this one, this part. You wanted to put this equation into Laplace trans, these both Laplace transforms. So for that reason, what we do, okay, so this is our y of s. Okay, so we can write this one as 1.22 by s minus 1.6 by s plus 1, where we can directly take the inverse Laplace. Here I'm going to write this thing as uh, so let's say we will separate first the denominator into s plus a whole square plus b square. Okay, so we can write that thing as s square plus s plus 25. Okay, we can write this as s square plus uh, 2 multiplied 1 by 2 multiplied s, so s can be written plus, okay, so this one is uh, here we have if you compare this one with a plus b whole square, we'll be having what, 1 by 4. This is like 1 by 4 whole square. Okay, so 1 by 2 whole square is 1 by 4 plus 99 by 4. Okay, so 99 plus 1 is 100 by 4 is 25. Okay, so this is nothing but now the first three terms, is there any doubt? First three terms, okay, you can put it like s plus 1 by 2 whole square plus the last one is 99 by 2 whole square. So now you can see this one, it looks like a s plus a whole square plus b square. Okay, so now, so the y of s can be written as, okay, so 1 by 2 by s plus minus 1.6 by s plus 1 plus So zero point 0.4 here again we have S, but if you see this, we need to have S plus A. Okay, what is A here? This one. Okay, we can write this expression as, okay, so S plus 1 by 2. Okay, minus 1 by 2 also we can put by S plus 1 by 2 whole square plus root 99 by 2 whole square. So this term minus, so the last term is as it is, minus 1.2. So there also, this is minus 1.2. There also we need to have B and B. So what we can do is, we can write B as what? B is this. Okay, so we can write it like, I'll move this one here. Okay, so we can write it like B is 99 by 2 divided by S plus 1 by 2 whole square plus root to 99 by 2 whole square, and again multiply with root to 99 by 2. Okay, so this one. Hope this is clear. Okay, any doubt here? Any doubt? Okay, so let me copy this one again. So we'll write the final time domain step. Okay, we'll write down the final time domain step. Here, this is 99 by 2 root to 99 by 2 we should have. Okay, so now direct step y of t. Take the inverse Laplace transform. Okay, so the first one is 1.2 u of t minus 1.6 e power minus t plus 0.4. Okay, so only this part is e power minus 1 by 2t, only this part. Okay, then this part. Okay, so that's going to be cos root 99 by 2t, first part. Then the second part is minus 1 by 2 e power minus 1 by 2t sine root 99 by 2t. Okay, so that is second part. Okay, then minus, so the other one 0.6 multiplication of these two. Okay, so e power minus 1 by 2t sine root 99 by 2t. Okay, yeah. Oh, sorry, this is going to be, this constant is going to be minus 1.1. Okay, so this is the final expression. So please do cross verify my answer. Okay, so this is the final expression. Is there any doubt in this problem? Any doubt here from this step to from how we are writing this step to this step? Any doubt?
No, no, sir.
Yeah. So this is the overall view of the problem. Okay. Next question. I think it is straightforward. First, we will go to the next question and come here, if time permits. Okay. So last question. So we have a given transfer function. We need to draw the Bode plot, find the phase margin, gain margin, and also draw the Nyquist plot. Okay. So, so let's start with the first question. So given transfer function is g of s equal to, so 8 by s plus 1 whole cube. Okay, so we have to draw the Bode plot, first question. So Bode plot. Okay, so what do we do to draw the Bode plot? Generally, step 1. Okay, so considering g of s as this, so 8 by s plus 1 whole cube. So we'll consider this as a transfer function of this nature, 1 plus ts whole cube. Okay, so we'll consider in this way. Then what we do is we'll form a table. Okay, if you remember our Bode plot examples, so we'll form a table. Okay, so let's say where we have number of terms. Okay, here we take term. Okay, then we take the corner frequency. Let me write it clearly. Corner frequency radians per second. Then we write the slope. So dB per decade. Okay, then we find the change of slope. Okay, so that is also dB per decade. Okay, so let's say how many terms we have. We have first term as 8. So second term as 1 by s plus 1 whole cube, or we can write it differently following the notation, standard notation. Okay, so 1 plus s whole cube. Okay, so here corner frequency, nothing is there. Here omega c as 1 by 1. So that is 1. Okay, here 0. Here the slope is minus 60. Okay, here there is no change of slope because there is no other slope. Here 0 plus minus 60. Okay, so which is nothing but change of slope is minus 60. Okay, I hope this is clear. Okay, yeah. So next step what we do is in this step 2. Okay, so we choose. Okay, so lower cutoff frequency very greater than the corner frequency. Okay, so let's say the corner frequency is 1. Let's say corner frequency is already 1. Okay, so we choose almost to 10% of that, which is 0.1. Okay, so approximately 10% of omega c1. Okay, so now at omega is equal to omega l 0.1. Okay, we find a. Okay, so that is 20 log. We find a as 20 log mod 8. Okay, so that is 8. 18.06 you'll get 18.06. Okay, next what we do is, okay, at omega is equal to omega c1. At omega is equal to omega c1, which is nothing but 1. Okay, so the a is going to be what? 0 plus, okay, 20 log 8. So that is also same value. Okay, next step 3. Step 3 what we do is, so we have choose, because omega c1 is 1. Okay, choose omega h is very greater than omega c1. Okay, let's choose omega c as 2. So generally we take 5 terms or 2 terms, 2 times the omega c. Okay, so now at omega h is equal to 2 radian per second. So we find a value. We find a value, that is slope change from omega c to omega h. Okay, here this is nothing but slope change from omega L to omega C. Okay, so here multiplied log omega h by omega c, okay, plus a value at omega c. Okay, so that how much we will get. Slope change is minus 60 log 2 by 1 because omega h is 2 plus, so this value is 18.06, which we have already calculated. So it is approximately equal to 0. Okay, so now you can see you have three values. Okay, so at omega L, okay, omega starting is uh, no, this has to be omega L. Okay, so you have omega L and you have omega C1 and you have omega H. Okay, so you can plot the Bode plot now. Okay, so you can plot it like mod z of j omega dB. Okay, so this is omega. Okay, so this is 0.1, 1 and this is 2. Okay, at 0.1 the value is what? So the value is 18.06. At 1 also the value is 18.06, whereas at 2 that is 0. Okay, so it means what? This is your plot. Okay, so this is going to be what? Minus 60 dB per decade. Minus 60 dB per decade. Okay, so now this is the magnitude plot. Whereas for the phase plot, what we do? So we already know that g of s is equivalent to 8 by s plus 1 whole cube. Okay, so g of j omega is what? 8 by j omega plus 1 whole cube. This means angle z of j omega is minus 3 tan inverse omega. Okay, minus 3 tan inverse omega. Similarly, you can find these three values, okay, at these three expressions when you have omega as 0.1, 1 and 2. Okay, these are the three values. Okay, so we can plot it as, so this is angle z of j omega. Okay, so you have 3.1, 1 and 2. Okay, so at 0.1 you will get this value as 17 degrees. Okay, and at 1 you will get this one as minus 135. At 2 you will get that is as close to minus 190, close to minus 180. Okay, so you can write down the values. Starting this is minus 17, here it is minus 135, and last one is minus 180. Okay, no. At 2 it will be, at 2 it will be uh, 10 was 2, it will be minus 270. Very high value. Please cross verify this answer. So we'll have minus 270. Okay, so starting with this point, okay, so it goes to minus 135 and it goes like this. Okay, so somewhere here. Okay, so this is the case. Okay, Now that is our first case to draw the Bode plot. Next question is to find the gain margin and the phase margin. Okay, so first let us go for first find the gain crossover frequency. Gain crossover frequency. So how do you find the gain crossover frequency? When magnitude becomes 1, the frequency at which the magnitude becomes 1. Okay, so then phase margin is what? 180 plus mod angle at gain crossover frequency. Okay, so now if you find it, 8 by root over omega square plus 1 whole cube equal to 1. Okay, so that is nothing but root over omega square plus 1 whole cube equal to 8. So this implies omega square plus 1 is 2, omega square plus 1 is 4. Okay, so then omega square is 3, then omega is plus root 3 minus root 3. Okay, so then phase margin. So phase margin is 180 plus. So angle is what? Angle we have already calculated this minus 3 tan inverse omega. So minus 3 tan inverse, okay, plus root 3. So we take only the positive values. We get what? 0 degrees. We get 0 degrees. So that is the uh, uh, gain crossover frequency and phase margin. This is gain crossover frequency. This is phase margin. Okay. Second is we find phase crossover frequency. Okay, omega PC. Okay, how do you find that? So angle you should find, and that has to be equivalent to minus 180. Okay, so how do you find minus 3 tan inverse? Okay, omega equal to minus 180. Okay, so tan inverse omega is 60. Okay, so omega is what? 1. Omega is what? Tan 60. Okay, so that is 1.732, which is nothing but, this is nothing but omega PC. Okay, so radians per second. Okay, now gain margin. So gain margin is equivalent to what? So 20 log. Okay, so 1 by z of z omega. Okay, so that is nothing but 20 log. Okay, so minus 20 log will become log minus g of j omega. Okay, so this is nothing but, okay, so minus 20 log. Okay, so this is 8 by root over 1.732. Okay, square plus 1. You simply substitute the uh, omega pc value here. You will get what? You will get that is as 1. Okay, so this is nothing but the phase crossover frequency and gain margin. Okay, any doubts as of now? Any doubt?
No, sir.
Yeah, so this is second problem. So now continuation to this problem, we have to draw the Nyquist plot also. Okay, so Nyquist plot. Nyquist plot. Okay, so we have g of j omega as so 8 by j omega plus 1 whole cube. Okay, so what is modulus g of j omega? So mod is 8 by root over omega square plus 1 whole cube. Next, angle z of j omega is so minus 3 tan inverse omega. Correct? Okay. So now in this case, now if you choose for drawing the Nyquist plot, what we do? So consider this g of j omega. So 8 by j omega plus 1 whole cube. Okay. If you expand it, what you get? So 8 by j omega cube plus 1 cube plus 3j omega square plus 3j omega a plus b whole cube. Okay, I hope this is clear. Okay, so if you expand this, okay, so I'm not going to do complete thing, so you please verify, write this one if you divide and multiply with these j terms. Okay, so 1 minus separating these imaginary and real parts, 1 minus 3 omega square plus so 3 minus omega cube whole square, this is real term, minus a 8 multiplied 3 omega minus omega cube plus 1 minus 3 omega square whole square, here also we have square, plus 3 omega minus omega cube whole square. This is what you will get. Okay, this is what you will get. I hope this is clear. Okay, so now in this, okay, so if you take imaginary part to 0, okay, so this entire part goes to 0. Okay, so let me write it here. uh, I'll put this one here. So if we write it here, okay, so if you take up imaginary part of g equal to 0, you will get what? Minus 8 3 omega minus omega cube equal to 0, only this part. So that means what? Omega is equal to plus or minus root 3. Okay, now in this, if omega is equal to tending to 0, okay, so this mod z, it becomes what? 8 minus j0 here. And omega is tending to infinity, this will become what? Mod z 0 minus j0. Okay, and if you take up real part of g, go taking 0, it will give you real part of g. Okay, no, here, yeah, this much is enough as of now. Okay, now for drawing the Bode Nyquist plot, what you do? So you consider the basic image of Nyquist model plot. Okay, so what is that model plot is? We have x-axis, you have real axis and imaginary axis. Okay, so you'll be having the model plot something like this. Okay, so we have A, B, C, D. Okay, 0 plus, infinity minus, 0 minus. Okay, so the arrow marks goes like this. Okay, so this is our model plot. In this model plot, generally what we do, we take the terms like this: a b 0 plus 2 infinity plus. Okay, so we take the terms Okay, so here omega mod g, okay, angle z. Okay, so let me take this term. Okay, so here we copy this. Okay, so we'll be having same thing four times we will do. Okay, so first one is AB, AB. Okay, so here we'll get 0 plus infinity plus. Next BC is infinity plus 2, infinity minus. Okay, so this is infinity plus 2, infinity minus. Next CD is, so infinity minus 2, 0 minus. Next AD is, or DA, 0 minus 2, 0 plus. So we have infinity minus 2, 0 minus, 0 minus 2, 0 plus. Okay. So we already know the values. If we calculate them, I'll be getting 8 here, 0 here, 0 here, minus 270 here, because we know the expressions for modulus and angle. Okay. So what are those? I'll write these expressions here. Mod G is what? 8 by root over omega square plus 1 whole cube. Angle Z is minus 3 tan inverse omega. So that's why you'll get here minus 270. And here also this will be 8, 0, 0 plus 270. And this one is minus 270. You'll get 0, 0 plus 270. This one is 8, 8, 0, 0. Okay, so that's what you get. Now, to draw the Nyquist plot, what we do, so draw the Nyquist plot. We take here. Okay, so this is real part. This is imaginary part. Okay, so first we start with A. Okay, so A is what? It is starting at 0, ending at minus 270. Okay, so this will be 0 plus 90 plus 180 plus 270 plus 360. If you come in the reverse, this is 0 minus 90 minus 180 minus 270 minus 360. Okay, so that's the way you proceed. So uh, first one is you start at somewhere here. You start at somewhere here. Okay, so you're starting at 0 and ending starting at 8. Okay, this is 8, starting at 0, 8, ending at minus 270. Okay, so you will start like this, go in this way, minus 270. Okay, so this is one point, this is another point. This is how you will proceed. Okay, next, so this is A. Okay, and this is A, this is B. Okay, next is BC. BC starts at 0, 0 and ends at plus 270. Third one is you start at C, okay, infinity minus, okay, and ends at it starts at plus 270, ends at 0. So it goes like this. Okay, so this is another point. This is T. Okay, now you can see. So this has minus 1 plus J0. Okay, so all the things put together. D and A, D and A, both the points are 8 only. So this is 8 plus J0. Okay, so this is Nyquist plot. Okay, now if you wanted to see, okay, if you wanted to see, so how many times encirclements, that also you can observe. Is there any doubt in this plot? Plotting Nyquist plot, any query or doubt? Any query or doubt? So for these four parts, A, B, B, C, C, D, so each one belongs to one part. I think previously also we have solved problems on this. Okay, any query? Any queries? Yeah, I think this problem. So, I mean, you can solve this second problem directly. So, where you can find the Laplace transform of U of S, okay, and you have G of S expression. You can directly calculate the second problem. Okay, so where Laplace transforms individually you can find, okay, and substitute in the G of S, you can find. So, Y of T is going to be what? Laplace inverse of G of S U of S. So which is nothing but Z of T. Okay, so convolution of U of T. Either you can do in the convolution way or you can directly find by using the inverse Laplace transform. Okay, so any queries on these problems?
No, sir.
Yeah, so coming Friday, what you can do is uh, I'll be attending this session. Okay, so if you want me to clarify your doubts, I can clarify if you come up with your doubts. It is better you post your doubts prior to this session, maybe by tomorrow evening or sometime. Okay, if you post it, I'll clarify all the doubts instead of I'll be taking 3 or 4 questions and solving them only. So you post your doubts, I'll clarify all the doubts. Okay, but but please try to post your doubts prior to the class so that I'll come up with the answers. Okay, instead of finding I mean clarifying the doubts instantly may takes time. Okay, so you please post your doubts prior to the class. Are there any queries in these questions or any other queries?
Sir, design assignment to deadline, can they extend, sir?
Yeah. Someone has sent a message. Okay, I'll discuss with the team and we'll try to extend it.
Sure, sir. Thanks.
Yeah, yeah. Okay, then if there are no queries, we'll end this session. Thank you.
Thank you, sir.